Okay, go ahead.
All right. This is the community team, August week 3, with our weekly demo. And here's Alex to show off some of the work he's done.
Yeah. Okay. So, can you guys see my screen?
Yep.
Something. Okay, I've got a very brief PowerPoint just to kind of try to go over what I've done this summer and explain what it's all for. So the thing that I've been working on is a new library for Deephaven that I've called Learn. And it is really cool. It's cool to just watch it work. I'm pretty proud of it. But what does it do? I think of it as a bridge between all of your favorite Python stuff and Deephaven's real-time stuff. So Python is really good at some stuff. It's got great data science libraries and very powerful things that you can do with AI and machine learning. And we have great stuff in real-time data technology. And this library is sort of a way to marry them. That's how I would shortly describe it. So I've got some bullet points. I mean, it's an integration between the cool Python stuff and cool Deephaven stuff. It has I think, a very simple, highly flexible user interface that basically allows users to do whatever Python they want with Deephaven tables instead of Python data structures like data frames or tensors. And I think that the most obvious cool application for this is like real-time machine learning stuff, real-time AI prediction. I think a catchphrase of real-time predictive analytics is flashy, and I think that just sounds cool and is attractive in itself. But of course, we have to show that it works, right? So the idea with this module is more or less we've got a lot of components that do different things, but as far as the user is concerned, things happen in 3 steps. First, data is picked out of Deephaven tables into Python data structures with no copies. It's all done in Java. It's very fast. That data is then computed on using user-defined Python functions that are essentially the meat of how the user tells Deephaven to interact with Python. And in that can be whatever you want. That's where the flexibility comes in, is that you're not tied to any particular Python libraries or ways of developing. You can pretty much do whatever you want, and this will accommodate it. And then the results of those calculations, those libraries that you've created as the user, are brought back into Deephaven tables. And what that means, and what I will demonstrate, is that you can do things like train neural networks and then do live predictions on data as it comes in. And all of the available predictions and values that are generated from these Python libraries can then be used in regular Deephaven queries because they're a part of the table, like anything else. So you get all the other cool Deephaven stuff for free. And it's a really, really flexible way to use really cool Python stuff with the real-time thing that Deephaven provides and the efficiency. So I'm going to do a demonstration. I've got a couple of things here, and then I have one more super cool example. Can you guys, is that readable?
Mm-hmm.
Yeah, okay. So I've got some data. It's a really simple data set. And the problem that I want to target is just a simple linear regression. I've got a bunch of variables, and I want to use them to predict this other kind of primary variable, right? So in this case, this is all insurance information. I would like to use the information of customers to predict how much their insurance is going to cost, right? That's the idea. This is just a simple kind of stats 101 problem. I use this big, horrible, long query to transform the categorical columns into numeric columns. That could be done better. But once I have my data in this fully numeric format, I have a lot of options. So as a developer, say I'm comfortable with scikit-learn. I like scikit-learn for these kinds of problems. I think I would like to use scikit-learn on this. It's not obvious to me exactly how to do that with Deephaven tables because scikit-learn likes data frames, right? So what we do, these are the couple lines of scikit-learn that we need. What we do is essentially wrap the Python stuff that we want to use for computations in a function, and then we're going to pass that function to my library, and it's going to take care of everything for us. So in this case, this function is going to take in some data. It's going to take in the target column, which is charges, and then all the features, which is the rest of them. It's going to train a linear regression model. It's going to make predictions using that model, and it's going to store them. Let's see. So I'm going to go ahead and run, just have that function. So that's step one. Step two, we have these gather and scatter functions. They basically tell data how to come out of and back into Deephaven tables, respectively. One of the kind of last things ahead for me that I'm going to try to wrap up in the next week is to sort of obscure this gather function from the user. I got a lot of work done on that today. At the moment, the user would either have to use this or define their own. Basically, this function just tells you how to pick data out of the Deephaven table. So if you want to pick data out row-wise by observations and group rows, this is where you do that. If for some reason you want to group things by columns, this is where you do that. But ideally, the user wouldn't see this. So that's just kind of a last thing that I need to polish to make that happen. And then the scatter function is right here. This is a user-defined function, and it basically tells you how to use the output of your Python function to get values back into the Deephaven table. So if I use these functions and I use the primary function in my library, which is called learn, you tell it what table you're coming from, you tell it which Python function is going to do all the work for you. You give it your inputs, as in which columns you would like to do computations on, which columns you would like your target and features to be, and then you use the output data structure to determine, exactly how data is going to be stored back into a table, and what that column is going to be called. So just as a very simple example, when I run this, you will see that it trains the model and then it gives back the same table with these predicted charges. Now, these are of data type object. There's a currently open ticket for casting columns in Deephaven tables. It's a bug that we have. Once that's resolved, these values right here will be, floats or integers or whatever it is the user would like. And it's all done in Deephaven tables. We don't use any slow conversions to Python structures to do these kinds of things. To show you how flexible it is, I can do essentially the exact same thing with a different Python library. There's another one that does similar stuff, and it's called stats models. So, the point here is that if there's a way as a Python developer that I'm comfortable doing things, I don't have to do anything different that I'm used to. We're not adding any complexity to the typical process of developing these kinds of things from a Python perspective. And this one's really cool because you get this nice little model summary stats models gives you, and I like this one a lot. So, that's cool. You can use typical Python machine learning stuff in Deephaven tables, and you never have to explicitly or implicitly convert to data frames. That's all right. What's really cool, and this is where I have to bring in some more code, so give me just a minute. What's really cool is when you start getting into real-time predictions. Real-time predictions are kind of what make me think this is awesome. So what I'm going to do, I'm going to train a neural network to predict the classes of the iris dataset. The iris dataset is one of our stock datasets, and the idea is if I tell you these 4 measurements about a flower, you need to tell me which flower it is, right? 0, 1, or 2. There's 3 different kinds of flowers. And so this is a textbook problem for using something like neural networks. They're typically really good at this. So again, we're going to use a function like my learn function, and it is going to train a neural network using this Deephaven table and the data that comes from it. It's going to give back a column of predicted values, and in this case, it performed pretty well. Now, what's cool is that now that this neural network is trained, we can use it to do predictions on data as it comes in. So this is kind of a what would you say, an artificial example, because you probably aren't going to have data about flowers coming in at 1,000 miles an hour, but you could, right? I mean, and this could be applied to anything. And so what I'm going to do, I'm going to create this fake live data set, right? And it's just going to start taking away all these flowers that I'm learning about all the time. I'm going to define my gather and scatter functions that determine how things get collected from this table and put back into the table. And then when I've done that, I am going to start making live predictions. And I forgot to put a round function, so these aren't truncated to a couple decimal places like I would like. But what it's doing is, as these rows are coming in, it's taking the data, it's shoving it through this neural network that I've trained. It's getting the predicted classifications for each of these flowers, and then the relative probabilities for classes 0, 1, and 2. So it tells you which one it thinks it is, and then it gives you sort of how likely it weights each one of these different classes, and it's doing it all in real time. So you can imagine what we could do if we were, say, working with the kind of famous credit card data set, which JJ and I talked about quite a bit. If you had data coming in, you could classify these observations as fraudulent or not on the spot, and using a Deephaven query, kind of siphon them into a second table with only, say, fraudulent observations. And then you could do, things that you might want to do to, maybe email anyone whose customer ID pops up in this fraudulent table. And it's all happening in real time. And at no point do we have to make slow conversions to Python things, and it's all perfectly integrated into Deephaven tables. And that means that it's perfectly accessible by the rest of the Deephaven system. So anything that you want to come out of Python, you can get it back into Deephaven, and this is a really easy way to do it. And then you can use your queries on it, and it's going to be live and fast in real time, just like everything else. And hopefully it's easy to use.
Yeah, I guess one other thing I'll add is this will work with GPUs if the backing libraries use them, and it's set up to do batch sizes. You can adjust that so that the whole calculation fits on the GPU.
Yeah.
Okay. Very cool.
So that's what I got. Do you guys have any questions for me?
So what data sets do you see this being used with to start?
I mean, I think in the context of what we're doing, we have a lot of live kind of time series data sets. So you might be able to imagine some kind of short-term forecasting neural network. I mean, if you're getting data in about transactions that are happening in the stock market, you may be able to do some kind of AI forecasting on those things as they come in. Like I said, the credit card data set is an obvious example. Anything where it would make sense to use machine learning, which increasingly is more and more common, you could do that with this. So the idea is that you are not at all restricted to developing in PyTorch or TensorFlow or scikit-learn. Use whatever you're familiar with, and you can use it on any data set that you'd like. And if that data set happens to hook into a Kafka stream and be real time, guess what? You get real time predictive AI for free. And that's I think that's pretty cool.
Cool. Any other comments for Alex?
I think it's very cool. My screen was obscured a bit.
Okay.
When you in the second example, you're like, oh, I like to have this statistical output.
Yeah.
Is my audio awful?
No, I can hear you, but I'm
so when that popped up, did you have to do extra wiring to get that into the web UI?
To get what into the web UI exactly?
You were talking about the statistics on of the output. I assume they were summary statistics or something. I didn't see them at the time.
Oh no. Okay. So no, what it's doing is it's just taking the output from the user-defined Python function that's doing all the work and determining how that output should be placed back into the table.
I think he's talking about the part that was printed to the screen.
Oh, the part that printed to the screen.
I think he's asking about P1, P2, and P3.
One more time?
I think he's asking about P1, P2, and P3, the additional probabilities of each.
I see.
I think he's talking about your second regression example.
Yeah. Did you print the screen? Okay, I'll just retract my question because I didn't see it and I don't want to throw the demo off.
I think that's just going to standard output.
Okay, so because I think those are the types of things might be really interesting to be able to render in frames in the UI on the dashboard.
Oh, okay, yeah.
Oh, I think I see what you mean. Yeah, I mean, so long as you can, like, if you want to make plots or you want to make, summary graphs or anything, as long as those things know how to deal with values in Deephaven tables, you can use it with this, because all of these values exist like anything else in Deephaven tables. So if you want to do queries on stuff, if you want to make plots, if you want to make dashboards, you can do that with this, and it's very, I guess, low cost. There's not very much additional complexity that we add to enable these things to happen.
Okay, good. And then the last thing is just that in transitioning, it looks like JJ's going to take this over. We should probably just note that to the group.
Yeah. JJ and I had a good long call about this earlier, and I kind of tried to explain most of this to him. But of course, I mean, if y'all have questions that come up at some point, I mean, I'll be available.
All right.
So.
Yeah, this is Alex's last week here.
Yes.
So yeah.
That's correct.
There we go.
Cool.
Next we've got JJ. So JJ's going to show us some new Deephaven types.
Okay. Let me share my screen. Okay, hopefully. All right, it looks like it's available. Is the text all visible and everything?
Yep.
Okay. So something I've been working on these last couple of weeks is a new submodule for the Deephaven Python module. It's called types, and essentially what it is convenience types to essentially call jpy.getType without having to call jpy.getType repeatedly in the Python console. So I have two examples up here in the Deephaven console. The first notebook does not use Deephaven types, and the second notebook does use Deephaven types. I actually demoed the same exact code a few weeks ago. This pulls crypto data from the website cryptocompare.com once every 5 times every 5 seconds. And so it uses dynamic table writer to do this. And so you can see here in this line of code, I've got this call to jpi.getType to grab the dynamic table writer object from the io.deephaven. And then you have to do the same thing here. When you define the table writer itself, the table writer object, you have to call jpi.getType to specify every data type that the table writer itself can expect in every individual column. And so when you do this, it works, but I think it's kind of ugly and it's inconvenient. And so in order to circumvent the need to actually use JPy repeatedly, I've added a new submodule called types within Deephaven. And in addition, I added the dynamic table writer object to the Deephaven table manipulation submodule, and that gets pulled into Deephaven by default. So for instance, if you do from Deephaven import asterisk, dynamic table writer gets pulled in automatically. So this is the second example with Deephaven. So on the first one at the top, we have import JPy. You can replace that in this particular example with these 2 lines, which is from Deephaven import dynamic table writer, as well as from Deephaven import deephaven.types as DHT. If you do from Deephaven import asterisk, both of these get imported by default. But for a lot of our documents, we're avoiding using the from Deephaven import asterisk. So I went with the explicit imports here. And then so you actually can completely get rid of the call to jpi.getType for dynamic table writer, since it is now actually just in memory for this. We have it available. And then once again, I can specify the dynamic table writer, and then instead of repeated calls to jpi.getType, which is not very Pythonic, we can use the Deephaven types module. I've got all of the Java primitives in here, as well as db datetime. And so if you run this, it does the exact same thing, but that portion of the code just kind of looks cleaner. Mm-hmm. And you don't have to keep using jpi.getType. So,
oh, wicked!
And that's all I got.
That does make it a lot cleaner. Anybody got any questions for JJ? All right, we'll move it on to Nate now to show us some application mode then.
All right, so just trying to share my screen. Mm-hmm. All right, so there's a lot going on behind the scenes here that we could show. We could do demos for hours and hours and hours, and I don't want to do that. So I just want to give you basically an overview of how this works. So on this particular machine, I have Deephaven set up. It's not running inside of Docker, but that's not important for this. But that's why the script looks a little bit different. To enable application mode, basically you just need to add this flag right here, and this other stuff on the end basically just gives it a default, so I can override it as I'm running it. In this directory, which is where I am right here, I actually have basically my first application, and it is a Groovy application. I have given it some sort of name that's an identifier that exists throughout, like as I change my application, this ID stays the same. So if I have layouts for the application, it'll still load things that I've exported in this app. It's got a human-friendly name, and right now, basically, this is just a file or a small application to kind of initialize my environment. So I've got basically 2 really small helper functions, ET, which is short for empty table, and TT, which is short for timetable. So I'm going to bring up the back end. And you can see here, basically, it found my application like so, or right here. And then it started the application. And at first, it found no exports. And that's because I'm actually overriding in the query scope, which you can see here, like that. So I'm going to bring this up and then show you. I can create, sorry. Oh, actually, while I do this, I'm going to demo something else. I'm going to bring up a second window, and I'm going to pop open this panels thing that the vendor worked on. And then I'm going to create an empty table of, something like this, 10,000 rows, and just include the row ID. So there's my big table, and over here, that table showed up in this panels widget automatically, which is pretty cool. And I can click on it and I can open it, and it's the same table that's in the query scope. And then similarly, like it works with any kinds of changes in there. So that's cool. You can see that my little helper function clearly worked. Now I actually also have this other little script that I added. It's also a little dummy thing that gets this. This is the new concept. There's basically this application context, and you can effectively add things to your application from inside your Groovy script. So here I add basically two fields, one I'm calling x2 and one x2_plot. And this is pretty similar to what I, just the empty table command that I just ran, and then the plot uses that empty table. I won't be able to show you all the things for the plot because for some reason that's not loading. And then I have a couple of extra tables here to demo one other in a second. So I'm gonna modify my demo here to point to my second file, and I'm gonna restart the backend without recompiling anything. So you're gonna notice this is gonna be relatively fast if it shuts down. There we go. And now it's starting, and it started, and you can see now here it's found two exports. So if I go back over here and refresh, you can even see it reloaded that T thing from the query scope because I changed T and T2 and T2 in that query scope. But I also have the application ID, and I can't erase this. I can't make it go away because it's not in the query scope. It's actually part of the application. And probably we'll have a display here to make it clear that this is x2 for the application versus x2 in the query scope or whatever, if we have to worry about overloading or how we're going to do that. You can see the UI also sees that I have this plot here. If I try to open it, though, it tries to load it as a table. And then one other thing I wanted to show you, which is pretty cool. I'm going to also open up T2. So, and open here. I'm going to sort this. So basically, T2 is a table that just simply, it's ticks with the last by, and it'll just go around and around. But one thing, if I do a hard refresh right now, the one thing that Bender worked on is that the layout will reload those tables, and you can see it's still going, which is fantastic. But even better than that, I can go back over here and say, whoa, I actually made a mistake. What I really want was actually just 10 rows instead of 100 rows for its cycling. But I wanted to go a little bit faster, actually a little bit slower. And now I could again just restart the server. It's waiting for, the reason it's so slow when it's stopping right now is because it's waiting for all the gRPC stuff to close down, and there are a bunch of things open. Okay, so you can see it came up again, found those exports, and when I refresh our window, you can see that it just picked up the new definition of T2 without any extra work, which is pretty cool. Any questions about the demo? Or Bender, is there anything else you want me to show that I didn't show?
I think you're good. Yeah.
I'm curious, like, what exactly is application mode, and what's the use case there?
Yeah, so application mode is basically a fancy way of saying that you can have prepared work that you want the worker to do at the time that it starts up. And so it will load all of your applications, such as connect to the market data feeds you want it to connect to, maybe create structures that you want to always be available. I was using it, for example, to customize my environment to create two variables called ET and TT because I'm too lazy to type empty table and timetable. I'm not actually that lazy, but it was just an easy thing to demo.
So how does it stop? Does it just go forever?
Yeah, application
Control C, or do we have a mechanism to tell it to shut down?
There is not a mechanism to tell it to shut down. You have to stop the worker. It's basically an equivalence of like a persistent query, I guess, or a replacement for it.
But with no controller.
Exactly.
And there is a mode where you and others can collaboratively work in the console in it until you turn that off.
Okay, so what would happen if you ran a query that's only static that should exit? Does it exit or does it keep going?
So you could call system.exit at the end of your script if you like. Nobody is going to stop you from doing that. Maybe not a good answer.
Yeah.
Okay, and if you do that, does that bring the whole system down, or does it just crash?
Oh yeah. So if you have a script that just generates static data, if it exports the static data, then it just like it's a run once and then it's exported forever. And in fact, like that's one of the primary goals. But you could also have applications that continue to generate new fields throughout its life cycle.
Okay, I guess the use case I'm thinking about is you have a discrete amount of work that needs to happen. At the end of it, it writes out a file or a table or something like that, and then it wants to go away.
Do you want the worker to be up or away? Because if you want it to be
away in this particular case.
Right. So you could do a system.exit, and that will close the entire worker.
Okay.
Right. Yeah.
Okay. Any other questions for Nate? All right. I think that concludes this week's demo. All right. Hope you had a good week, and I hope you have a good weekend. Bye.